Welcome to next session, my dear friends. In this session we are going to learn the comparison between the slow sand filter and rapid sand filter, and then we are going to learn the pressure filter, briefly about pressure filter, and then we will learn design of filters. Okay, let us start our session. Comparison of slow sand filter versus rapid sand filter. So slow sand filter parameter, slow sand filter, and rapid sand filter. So let us start with the first property, that is size size of the filter. Size of filter. So the slow sand filter, as I already told you, it ranges from 100 to 2000 meter square. So earlier I have told this is 200, it's not 200, it is 2000. It ranges from 100 to 2000 square meters. So the requirement of the area is very large in case of slow sand filter, whereas in case of rapid sand filter it is 10 meter square to 50 meter square or 100 meter square, maximum 100 meter square. Okay, this is the area requirement, surface size of the filter needed. So slow sand filter needs more area, more size, and rapid sand filter size will be lesser. And next is filter media of sand. Filter media of sand. So the properties of filter media of the sand. In slow sand filter, if you see, sand grains are finer. Sand grains are finer. Sand grains are finer. So that means here D10 varies between D10 of slow sand filter varies between 0.20 to 0.30 mm, 0.20 to 0.30 mm, and Cu is approximately equal to 5. Cu is equal to 5, whereas in rapid sand filter sand grains are little coarser. Sand grains are coarser because in order to have more rate of filtration, we need coarser material so that the void spaces will be larger. Here D10 varies from 0.45 to 0.70. D10 varies between 0.45 to 0.70 mm. See here, the size is larger, and Cu is approximately 1.3 to 1.7. So if you look at, see here, the values are not important. The important is the pattern. Here the sands are finer. Here the filter media is coarser. Here D10 is smaller. Here D10 is larger. Here we prefer uniform material. That means coefficient of uniformity is nearly unity. Here coefficient of unity is more. That means here we use well graded sand, but here we use uniformly grained sand in order to have more voids spaces so that the rate of filtration will be more. So that is why we keep larger diameter and also uniform material here. That is poorly graded. It is well graded. That is filter media of sand. And base material, and here thickness of sand. Here the thickness is 90 to 110 centimeter approximately. It is 1 meter. Generally we keep it as 1 meter, and here it is 60 to 75. Here the thickness is 60 to 75 centimeter. Thickness of sand is lesser here, thickness of sand media is more here. Okay, 1, 2 and 3. Base material gravel. Here in slow sand filter, base material gravel will have a size of 3 mm to 65 mm. Size 3 mm to 65 mm. Whereas the size of the gravel there is little lesser, 2 mm to 50 mm. Size is 2 mm to 50 mm. See, if you observe the difference here in sand we are taking coarser, in gravel we are taking finer. In sand you are taking coarser, in gravel you are taking finer, because I told you already, here in rapid sand filter gravel also participates in the filtration process. So that is why it is necessary to have finer material. Here the gravel is only a supporting material, that is why the size of the gravel is kept higher. Here the size of the gravel is kept lower in case of rapid sand filter. Okay, and the thickness 30 to 75. Thickness is 30 to 75 centimeter, whereas here it is 45 to 60. Whereas here it is 45 to 60. 45 to 60 centimeter. This is the base material gravel. And next comparison is coagulation. Generally the water in slow sand filter, whatever the water we are sending into the slow sand filter is directly from primary sedimentation tank. So here in secondary slow sand filter the water will be coming from primary sedimentation tank to slow sand filter. The water will come from primary sedimentation tank to slow sand filter. So that is why in primary sedimentation tank there won't be any coagulant present. So that is why in slow sand filter there won't be any coagulant present. No coagulant is required or is present, whatever it may be. Whereas here in rapid sand filter we derive the water, we bring the water from secondary sedimentation tank, so to rapid sand filter. So here coagulant is needed, coagulant is present or coagulant is needed. Okay, in this rapid sand filter it gets water from the secondary sedimentation tank. These are some of the comparisons. Let us erase it and continue the rest of the comparisons. So next is rate of filtration. So the rate of filtration here, it is already I have told you, here it is 100 to 200, 100 to 200 liter per R per meter square, whereas here 3000 to 6000 liter per R per meter square. So this is approximately 30 times of the rate of filtration of the slow sand filter. Rate of filtration of slow sand filter. So method of cleaning. Method of cleaning. Method of cleaning. So method of cleaning is here scraping of top layer. So scraping of top layer. Scraping of top layer of 1.5 to 3 centimeter thick. So this is the method of cleaning. Here the method of cleaning is backwashing with a rate of backwash which is equal to 5 to 7 times of rate of filtration, okay, for a duration of 10 minutes. For a duration of 10 minutes. So this is backwashing technique. Backwashing technique we use here to clean the rapid sand filter. And period of cleaning. Period of cleaning I already told you this, 1 to 3 months, and here 1 to 3 days is an approximate values only, just to remember easily. You can remember, that is why we are taking like that. Okay, so amount of wash water needed, amount of filtered water needed to wash the filters. Here it is 0.2 to 0.6. Here it is 0.2 to 0.6 percentage of filtered water. Here it is 2 to 5 percentage of filtered water is needed for cleaning. Here 2 to 5 percentage of filtered water is needed for cleaning. So these are the important comparisons. And one more last very important comparison is the efficiency of removal of color and bacteria. So efficiency of removal of color and bacteria. Efficiency of removal of color and bacteria or microorganisms, or simply microorganisms. So here the efficiency of removal of color and efficiency removal of bacteria. For slow sand filter, the slow sand filter is effective up to a removal of bacteria 98 to 99%. So it can remove up to bacteria microbial removal or bacterial removal is 99.99%, whereas less effective in color removal. Here rapid sand filter is 98 to 99% effective in color removal, but less effective in bacteria removal. What is the reason? Why this slow sand filter is efficient in removal of bacteria but less effective in removal of color? Why this rapid sand filter is effective in removal of color less effective in removal of bacteria. So simple, very simple to understand. Let us understand this with the concept. See, in slow sand filter, generally the water comes from primary sedimentation tank. Okay, the water comes from primary sedimentation tank. So in primary sedimentation tank there won't be any floc. In the water which is coming from primary sedimentation tank, in that there won't be any floc or coagulant is present. So due to the absence of the coagulant, floc is absent. Due to the absence of the coagulant, floc is absent. This floc will help to remove color causing chemicals, compounds such as iron ion, manganese ion. This floc will stick to the filter media and it helps in removal of the color causing compounds. As this floc is absent in the water which is coming from primary sedimentation tank, that is going into the slow sand filter, so that is why it is less effective in color removal. So similarly, in the same manner, rapid sand filter generally gets water from secondary sedimentation tank, in which there is a lot of amount of unsettled floc will present, which will settle in the filter media, so that helps in the effective removal of color causing ions. Okay, so that is the reason why color is effectively removed in the rapid sand filter, why it is not effectively removed in slow sand filter. So the reason, so as the water coming into slow sand filter is derived from primary sedimentation tank, where coagulant is absent, So the floc which is formed out of this coagulant is formed from this coagulant will enter into a rapid sand filter which is unsettled in secondary sedimentation tank. This unsettled floc present in rapid sand filter helps to remove color causing compounds. Hence the rapid sand filter is effective in color removal than slow sand filter. So as the water coming to slow sand filter is derived from primary sedimentation tank, where coagulant is absent, the floc which is formed from this coagulant will enter into the rapid sand filter which is unsettled in SST, secondary sedimentation tank. This unsettled floc present in the rapid sand filter helps to remove color causing compounds. Hence the rapid sand filter is effective in color removal than SSF, slow sand filter. So this is about color. What about the bacteria then? See, when the bacteria is present, when the bacteria is present in the water, when the bacteria is present in the water, okay, so that bacteria will grow only when the food is present. When the food is absent, then the bacteria will die. When the food is absent, then the bacteria or microorganism will die. So when food will be absent, when food will be absent, let us see. See, this is the slow sand filter. This is slow sand filter, and this is the filter media. This is the filter media. Okay. Now, when the water is passing through this filter media, the organic matter present in this water will be arrested, will be captured inside the filter media pores, inside the filter media pores. Now, when this organic matter is being arrested, then the microorganism will come and start eating this food or organic matter, and it will form a gelatinous layer called dirty skin. Okay, gelatinous layer called dirty skin. So this is called what? Dirty skin. So this dirty skin will act like a filter. It is also acting like a filter and helps in effective removal of finer particles. Now once this layer is fully formed, then organic matter whatever present in the water will be trapped here only. But the bacteria which is already came from the food already present, so those bacteria only formed this dirty skin. Now this bacteria, whatever the bacteria which has formed this dirty skin, will come onto the other side of the dirty skin. So this is some bacteria which came to the other side of the dirty skin, and this is the bacteria. Here bacteria will be less but food will be more. Here bacteria is more, food is not passing through this layer. That means here food is less, microorganism is more. So when food is less, then food will be completely consumed. Then microorganism will not find food anymore. Then what happens? This microorganism will eat other microorganism and they will survive. This is called endogenous respiration. So endogenous respiration means endogenous respiration. So when no food is available, then bacteria feeds on other bacteria and survive. So this is the thing, but endogenous respiration. When the food is very less here, then endogenous respiration takes place. So due to endogenous respiration, the bacteria concentration will decline. The bacteria concentration will decline in the effluent. So that is why here in slow sand filter, so the bacteria removal is more. So hence in slow sand filter, Hence in slow sand filter, so bacteria removal efficiency is more. Bacteria removal efficiency is high. Okay. Now, so why this is not happening in rapid sand filter? Why this is not happening in rapid sand filter? In rapid sand filter also this dirty skin will form. In rapid sand filter also dirty skin is forming. Then why it is not takes place in rapid sand filter? In rapid sand filter, as the rate of filtration is high, the dirty skin layer cannot sustain for longer duration. It gets broke down. So here in slow sand filter the rate of filtration is very slow, so that is why this dirty skin is safe, it will not break down. But when the rate of filtration is very high, because of the more rate of filtration, if you take a small paper and just filter paper and you are pouring water drop by drop, then filter paper can filter the water. If you same filter paper, if you are pressurizedly send some water, then the filter paper will tear off. The same thing happens with the dirty skin also. This is also like a filter paper. This filter paper can bear some amount of filtration, but if you increase the force of water, then what happens? This filter paper cannot sustain. So because of which, when the filter paper thickness is building up, as well as when the rate of filtration is also building up, somewhere or other this filter paper will break down and all the food will come down again. So then the bacteria can survive now. So that is why the efficiency of bacteria removal is more in slow sand filter. So though the Scumiciaceae forms in the rapid sand filter, but it cannot sustain due to the heavy rate of filtration. Okay. So because this is the reason why slow sand filter is effective in bacterial removal. Okay. So now we are moving on to our last concept, that is design of brief specifications of pressure filter. So what is pressure filter? Generally pressure filter we don't use for public water, municipal water supplies. We use for gated communities or for limited supplies we prefer pressure filter. Okay, pressure filter, it's not a gravity filter, it's the name itself says it is pressure filter. That means the water is sent under pressure. The water is sent into the filter media under pressure. Pressure filter. So the pressure filter will be like this. So there will be a filter media or a base material. On base material, so water is sent here. This is the outlet, this is inlet, outlet. Generally the height of the filter is ranging from 3.5 to 8 meter. So here the height of the filter 3.5 to 8 meter it will be present, and the diameter, so this is the diameter, This is the diameter. So D dia varies from 1.5 to 3 meter, 1.5 to 3 meter. So these values are not needed for the examination, only for the sake of knowledge I am telling. The rate of filtration is very high, 6,000 to 15,000. The rate of filtration is very high, 6,000 to 15,000 liter per hour per meter square. Liter per hour per meter square. And the D10 size of the filter media, D10 is equal to 0.5 to 0.6 mm, 0.5 to 0.6 mm, and the coefficient of uniformity here also it is nearly uniform, that means approximately 1.2. we maintain the coefficient of uniformity, and the surface area, if you want the surface area of the pressure filter, surface area pi d square by 4 is equal to Q by rate of filtration. So surface area is equal to Q by rate of filtration. If you know the rate of filtration, if you know the what is the requirement needed for a community, then we can design the diameter of the pressure filter. We can design the diameter of the pressure filter. Okay. So generally we don't use for public water supply. We use for some confined supplies like industrial water supply and community, gated communities water supply, like that. So this is enough about the pressure filter. Now we are moving on to the last concept of our topic, that is design of filter. Design of filter. And after filtration we are going to discuss disinfection. After disinfection, miscellaneous water treatment. After water treatment, we will discuss the distribution system, where after completion of distribution system, water supply is over, we will enter into the wastewater engineering. Next is design of filter. Design of filter. See what is meant by the design of a filter. What is meant by design of a filter? Because in filter the specifications are defined already. What is the depth of the filter media is required, what is the depth of the gravel is required, or what is the under drainage system is required. Everything is so. In terms of height, we have no control. In terms of height, but we have control in terms of surface area. So designing of filter is nothing but fixing the surface area. Designing of filter is nothing but determination of surface area if it is slow sand filter. Okay, if it is a rapid sand filter, then we need to design. So what is the velocity of backwash, so what is the expanded bed porosity, what is the expanded bed thickness, all those things will come. Whereas if it is only slow sand filter, there won't be any backwashing. So here in this case only determination of surface area is enough. So how to determine the surface area now? Surface area will have a unit of meter square, right? Surface area will have a unit of meter square. So if you look at a filter, so let us say this is a filter. Okay, this is a filter. So from this filter, the water which is coming from this filter will be taken by some community. So these people need amount of Q. So their demand. So this is the water which is coming out of the filter to the community. So these people need some amount of Q. That means million liter per day. So this community needs a water of this much million liter per day, or else this we can write it as in terms of liter per hour also. Okay, we can write this as million liter, I will convert into liters, and day I will convert into hours. So I can also write this as Q will be the demand of the water by the community is in the form of liter per hour. And what is rate of filtration of filter? So rate of filtration Generally we define rate of filtration in terms of liter per hour per meter square. So here the rate of filtration unit is liter per hour per meter square. Here the unit of the demand is liter per hour. So what is total surface area now? If you divide this with this, then we will get the surface area of the filter. Okay, so total surface area of a filter TSA is equal to Q by ROF. So if you do Q by ROF, that means Q is in liter per hour and ROF is liter per hour per meter square, then we will get the total surface area in meter square. So once you get the total surface area, so sometimes we don't provide this total surface area in the form of a single unit. We sometimes provide into number of unit. For example, now area of each unit is surface area of each unit of filter is A. So the number of filters needed is equal to N, which is equal to total surface area by area of individual filter or each filter. Area of individual filter, that is surface area of individual filter, which is equal to total surface area by A. Then you will get the number of filters needed. Generally we keep one filter as standby. So the number of filters needed is equal to N plus 1. So if the requirement is N, then we will add 1 to it and we will provide one more filter in order to take care of maintenance. When you kept one filter in maintenance, then what happens? We need to have one filter standby. That is why generally we keep it as N plus 1. So in case of rapid sand filter, this is for slow sand filter as well as rapid sand filter also. But in rapid sand filter there will be little extra they may ask in the exam. Let us see that. In rapid sand filter also we will find the surface area and number of filters using the same methodology. Apart from that, there will be some more terms are needed, some more things, some more parameters needs to be discussed which are important in the examination. So here in rapid sand filter, they will ask you percentage of filtered water used in backwashing. If they are asking you percentage of filtered water used for backwashing, So percentage of filtered water used for the backwashing is nothing but volume of the backwashing water, and divided with volume of water filtered between two successive backwashes. backwashes. So that means, so you have did backwashing. Now the filter has commissioned again, so that it has started filtering water. So this is the amount of filter. This is the amount of water filtered. Again you need to do backwashing. So this filtered water you will use for backwashing again. So once the backwashing is completed, now you have started filtering the water, and this is the total volume of filtered water which will be used for the next backwash. So that is why the volume of water filtered between two successive backwashes, that is the volume of filtered water available with you. In this, some amount of water you have used for backwashing, that is volume of backwashing water. This is the ratio he is asking. So let us first define what is volume of backwashing water. How to determine the volume of backwashing water. Backwashing water. See here volume, that means in liter, we want it in liter. We want it in liter. So here if you want it in liter, so the rate of backwashing, if the rate of backwashing is ROB. So what is ROB? ROB is rate of backwashing. Rate of backwashing. Okay. So multiplied. Here rate of backwashing will have a unit of liter per hour per meter square. This is rate of backwashing. Multiplied with duration of backwashing. So DOB is duration of backwash. Duration of backwashing. So DOB is duration of backwashing in hours, into area of the filter, area of each filter, because we do backwashing each filter. We don't backwash all the filters at a time. We will do backwashing for each filter. That is why we are taking here area of each filter. Area of each filter. Now here we are getting the volume. So liter per hour per meter square into R. R gets cancelled. Area of each filter in meter square, that means meter square is cancelled. So we are getting the volume of the backwashing water VB in liter. Similarly, volume of filtered water between two successive backwashes. So that is volume of filtered water in liter. So rate of filtration again in liter per hour per meter square. Duration of filtration in R, and area of each filter. Area of each filter in meter square. So this is volume of the filtered water. This is volume of the backwashing water. So take the ratio of it. So here the ratio of this. So percentage of filtered water used for backwashing, which is equal to, so volume of the backwashing water means rate of backwash multiplied with the duration of backwash multiplied with area of each filter divided by rate of filtration, duration of filtration, area of each filter. So here area of each filter will get cancelled. So it is simply ROB DOB by ROF DOF. ROB DOB by, so ROB DOB by ROF and DOF. So this is the percentage of filtered water used for backwashing. Percentage of filtered water used for backwashing. Now, so volume of water here one more thing which is necessary is sometimes they will give you the relationship between rate of backwash and rate of filtration. For example, they will tell, so rate of backwash is 5 times or 6 times of rate of filtration. Then you can take rate of backwash as 6 into ROF. We can cancel it. Okay. Sometimes, see, one more thing very, very important here is, they will say like this: the filter is operated for 24 hours with a maintenance period of time 10 minutes, with a maintenance period of, or with a backwashing time of, 10 minutes. So then in this case, if the filter is operated for 24 hours with a backwashing time of 10 minutes, means here what is the duration of backwash? It is 10 minutes. What is duration of filtration now? So 24 hours minus 10 minutes. So 24 hours into 60 minus 10. So this is the duration of filtration, 24 hours. Each hour it is 60 minutes. So the filter is working only for 23 hours 50 minutes only. It is not 24 hours. Though he is saying that the filter is operated for 24 hours, that means in that 24 hour 10 minutes is backwashing time. So the filter has worked for 23 hours 50 minutes. So here the duration of filtration you need to fix with like this one, not 24 into 60 simply. Duration of filtration is the time between two successive backwashes. Okay, so this is what we need to remember about the design of the filter in rapid sand filter as well as slow sand filter. Okay, there is some miscellaneous types of filters apart from single media. We have discussed all the single media filters, and now there are some filters which are dual media filters. Dual media filter I have already told you. So there will be two medias. One may be sand, another may be anthracite coal. One may be sand, another one may be garnet. So one may be anthracite coal, one may be garnet. So there may be two combinations, different combinations are there, but in each combination there will be two types of filter media we use at a time. Then it is called dual media filters. Okay, dual media filter. So this is all about the filtration. So what we will do, we will discuss the disinfection concept in the next class. Thank you so much.